Okay, I'm going to just do a quick video on the calculator functions for the normal curve, which those two calculator functions are normal CDF and inverse norm. So where we go in the calculator to get those calculator functions, we hit seconds and vars. It says distribution right above the vars key. And normal CDF is number 2, and inverse norm is number 3. So those are the two calculator functions that we're going to be using in this presentation. Okay, here's the first example. A survey by the National Retail Federation found that women spend on average $146.21 for the Christmas holidays. Assume the standard deviation is $29.44. Find the percentage of women who spend less than $160. Assume the variable is normally distributed. Okay, I'm still going to go ahead and draw a picture of what's going on with this prompt just so that we can get a visual of what we want to find. So we have a normal curve that's centered at an average of $146.21. And then we want to find the percentage of women who spend less than $160. So 160 is above the mean, but we're shading to the left. So that's quite a large area that we're trying to find. The calculator function that we're going to be using for this is the normal CDF. So the normal CDF function is used when we want to find a particular probability. How you use this function is you first put in a number that represents where the shading begins on the left side of the normal curve. So technically, the left side of the normal curve for this one, the shading goes down and it's going to continue to go down really to negative infinity. So the calculator recognizes -1 E99 as the smallest possible number in the calculator. And we'll go over buttons in just a second. Then the second number is where the shading ends. So for our example, our shading ends at 160. We then have to tell the calculator what is the mean. Our mean is $146.21. And we also have to tell it what is the standard deviation, which the standard deviation in the prompt was given as $29.44. Ooh, I'm getting awfully close to the edge of that slide. Sorry there. Okay, so let's go ahead and plug that in. So we're going to hit second vars again to get to that menu. We select number 2, normal CDF. And this particular calculator does bring up a menu for me, but if you do not have that menu, you want to type it in exactly as I have it written on the screen. So the lower is the negative infinity or -1. The E is second comma 99. So that's actually scientific notation. It means -1 times 10 to the -99th power. I'm sorry, -1 times 10 to the 99th power. The upper is 160. The mean is $146.21. And the standard deviation is $29.44. We're going to click paste. Now, if you notice, guys, the calculator is going to show me exactly how I have it written out on my screen. So if you do not have that little menu, again, just make sure you have it written in the same way. All of those numbers need to be separated by commas. The comma is right above the 7. Okay, click enter, and it is going to calculate that probability for me. So this probability would be, if I change that to a percentage, 68.0, I'm going to round that to 3%. Okay, for our next example, it says for a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that would qualify people to participate in the study. Again, I'm going to go ahead and draw out a picture so we know exactly what we're trying to find for this scenario. So we have a normal curve centered at a mean of 120. I'm just going to pull the standard deviation off to the side. The standard deviation is 8. We want the middle 60% of data. So we want this area to be 60%. Okay, so if we think about some areas of the curve that would be left over, since we have 30% on either side of the mean, 60% would mean 30 on the left and 30 on the right. We're left with 40% for these two tails. So that would mean 20% on the left and 20% on the right. So this area would be 20% or 0.2. This area would also be 20% or 0.2. And in the middle, again, we have 0.3 and 0.3. So remember that normal curve is symmetric. So any of those values that are in the center, kind of want to split those between the two sides. Okay, the calculator function that we would use for this is inverse norm. Because we're not looking for a probability, we know those probabilities. We know the areas that are under the curve. It is the lines or the x values that we want to try to find. So we want to know what is this line's blood pressure and what is this line's blood pressure. Because we know it's centered at 120, but again, we don't know the boundaries for that middle 60%. So inverse norm is what we use anytime we know the probability and we're trying to get the data value. So what we need to do is enter an area to the left. So this 0.2 is an area to the left of this lower boundary. So that is the value that I'm going to put into normal CD or inverse norm rather. The next two numbers have to be the mean, 120, and the standard deviation, which in this case is 8. We go to the same location in the graphing calculator, second vars, but we choose inverse norm, which is number 3. The area to the left is 0.2. The mean is 120. And the standard deviation is 8. Now, on this particular calculator, it is asking me, is that an area to the left? Is that an area in the center? Or is that an area in the right? Now, if you do not have that little menu, the calculator defaults to area to the left. So that's why I'm showing this as area to the left here and not center or right. Because if you do not have this menu, then you always want to use the area to the left. And click paste. Notice that it is entering exactly the way I entered it here, except for that word left. Again, if you do not have the menu, you just want to enter it like I have it on the screen. Okay, if we click enter, it is going to tell me that that lower boundary is at 113.2. I'm going to round that to 7. But we also need the upper boundary as well. So let's talk about how we would enter that. Our mean is not changing and our standard deviation is not changing, but our area to the left would change. So if I want this line, I would want the area to the left of that. So I would want this 0.3, this 0.3, or the entire 60% that we started with, plus the 20% in that left tail. So if we add that up, 60% plus 20%, that whole entire left shaded region would be 80% of the graph that would be shaded. So 0.8 is the area to the left. Again, we're keeping the same mean of 120 and we're keeping the same standard deviation of 8. Again, this is an area to the left. I'm showing that because if you do not have this menu, you always want to use area to the left. And paste. Oops. Oh, it did not change my area to 0.8. Sorry, guys. Let me go back and enter that one more time. I thought I had entered 0.8, but maybe I didn't. So 0.8 this time. And paste. Okay, and we get the upper boundary, which would be located to the right of the mean, and that is going to be 126.72, or rather 73, and that represents the range of the middle 60% of blood pressures. Okay, here's the last example that we're going to take a look at. The average age of a vehicle registered in the United States is 8 years or 96 months. Assume the standard deviation is 16 months. If a random sample of 36 vehicles is selected, find the probability that the mean of their age is between 90 and 100 months. Okay, again, I'm going to go ahead and draw a picture of what this distribution would look like so I'm clear on what we're finding. So we have a normal curve that is centered at 96 months. That was the mean. We want to find the probability that the mean age is going to be between 90 and 100. So this is the area that we want to find. However, we're not just selecting a randomly selected vehicle, we're selecting a group of 36 vehicles, that's N, and we want to find the probability that their mean is between 90 and 100. So central limit theorem comes into play here. So anytime we have a group of individuals and we're trying to find the probability that that average is between certain values, we have to make an adjustment to the standard deviation. So we have to find the standard error, which is the standard deviation divided by the square root of n. So our standard deviation for this particular problem is 16, and we're going to be dividing that by the square root of 36. So when we enter our standard deviation into this calculator function, we need to make sure that we're entering this value rather than just 16. Okay, so let's go ahead and talk about it. We want to find a probability, so that is going to be normal CDF. For this one, the shading starts at a value of 90 and it ends at a value of 100. This distribution has a mean of 96, and we just discussed that the standard error is 16 divided by the square root of 36. Okay, to enter that into the calculator, we're going to second vars and selecting normal CDF. The shading starts at 90. It ends at 100. We said it has a mean of 96 and a standard deviation of 16 divided by the square root of 36. And paste. Okay, that probability is 92.1%. So don't forget about that central limit theorem, guys, when you're doing these application questions. And again, the easiest way to identify that is we're going to be selecting a sample. So an n value will be given to us. And the question will ask you to find the probability that the mean of those individuals or that group is between certain values or greater than a certain value or less than a certain value. So we've talked about the calculator functions. Just want to recap that if you need negative infinity, you are going to enter negative 1e, which is second comma in the calculator, 99. We did not do an example that involved positive infinity, but if you need positive infinity, you're going to enter positive 1 E99. That's the largest value that the calculator will recognize. So again, that's scientific notation, and it means 1 times 10 to the 99th power. So that is a humongous number. Again, those E's are located, you hit second comma, which is right above the 7 to get that E. It is not the alpha E key. Okay, so that's the scientific notation E. Okay, so I just want to do a quick video on those calculator functions in case you wanted to use those. Okay, guys, this is the end of this video.